Right, so now we're dealing with C. So now the given equation, it has cos theta cos 10 and plus sine theta sine 10 is equals to 0,365. Now, if you can check, this is going to be a compound angle, right? Because now you can see it's going to be cos and cos and sine and sine. And the given two angles is going to be alpha and 10 degrees, right? But remember that this is going to be a compound angle for cos. So it's going to be cos, then the given angle is going to be alpha. Then for cos, it's going to be minus 10 degrees. Then we have 0,365. Then from there, we have to find an angle, the ref angle of cos. So it's going to be 0,365. And that ref angle, it's equivalent to, let me check, so it's going to be shift cos 365. So this is going to be equivalent to 68,59 degrees. Now this is going to be your ref angle. So now we have to check where is cos. Remember, it's going to be a positive value. So where is cos positive? So using your case diagram, cos is positive, your first and your fourth quadrant, right? So this is going to be alpha. Remember, this is going to be the angle that is included there. So it's going to be alpha minus 10 degrees. Then this is going to be 68,59 plus K 360. K is an element of integers. Then from there, you're going to transpose 10 to the other side because we want alpha then. So this is going to be, so when you transpose, it's going to be 78,59. Then K 360. Right. Then from there, we're going to the fourth quadrant. So we have alpha minus 10 degrees. Then it's 360 minus ref angle is going to be 68,59 degrees. And it's K 360, then K is an element of integers, right? Then 360 minus 68, we are going to get 291,41 degrees. Then it's going to be 360. Right. Now we have to transpose. So when you transpose 10 to the other side, it's going to be, so this, sorry for that, so it's going to be alpha. Then when you transpose 10 to the other side, it's going to be 301,45 degrees. Right. And that's going to be your final answer. Right. So now our focus will be on D. So now with D, we have cos x plus square root 3 sin x equals to square root 3, right? Now, neither of these ratios can be replaced by their identities, right? So now for this one, the hint is that it's more of a compound, right? Compound angle. Then this is how it works. We know that this is going to be 1. We know that it's 1. And we know that it's cos x plus square root 3. Then we have sine, right? Now, in order to balance this equation, we have to divide by 2, right? You have to divide by 2 both sides to create the values of, so this is going to be over 2, this is going to be over 2, right? So meaning that you have 1 over 2, then you have cos x plus square root 3 over 2, then you have sine x, then you're going to have square root 3 over 2. Now, these values of half and square root 3 can be replaced with their trigonometric ratios of special angles, right? So now it depends on which one you choose, but at the end, your compound should make sense, right? So now we're going to start with the first one, half. Half can be cos 60 or it can be sine 30, right? So I'm just going to choose sine 30 degrees cos x. So we know that if it's sine and cos, then it's going to be sine, it's going to be cos and sine, right? So meaning that it's going to be cos 30 degrees and sine x is equals to, right? Now we have square root 3 over 2, right? Remember, this compound, its compound angle is going to be for sine. It means that both sides has to be sine, right? So now we know that square root 3 over 2 is going to be sine 60 degrees. Why are we choosing sine? Remember that we have to write two equations but with the same ratio, and at the end one ratio, its angle is going to be the ref angle, right? I think that was example, let me check. Example 31 on your textbook on page 167, right? So equations in the form of sine theta is equals to sine beta, right? So now this can be written as sine x plus 30. Remember, the sine remains the same. Then you have sine 60 degrees. So now this is going to be the included angle, then this is going to be the ref angle. Now this is going to be angle and the ref angle. So we check where is sine positive, right? We know that sine is positive on your first and your second quadrant. Now the angle is going to be x plus 30 degrees, and it's going to be your ref angle of what? Of 60. Then it's going to be plus k 360. All right. Then you're going to transpose 30 degrees to the other side, so it's going to give you 30 degrees, k 360, right? Then with this one, then from there you're just going to go to your second quadrant, so it's going to be x plus 30, then it's going to be 180 minus your ref angle, which is 60. Then we know that x at the end, it's going to be, so it's going to be 180 minus 60 minus 30. So it's going to be 90 degrees. Then that is going to be your general solution. Remember that if it's in this form, you have to make sure that you check, because this is a hint that you have to divide by 2 so that you can have the values of the special angles, right? So dividing by 2, remember 2 is going to be that constant ratio, constant radius, so meaning that you're going to divide by 2 across, right? Then from there, it's going to be 1 over 2 square root 3 over 2 square root 3 over 2. Then you're going to check which value we're going to use, which value will correspond with its trig ratio, right? Now then from there, you know that okay, if it's sine, cos, cosine, then you know that your compound angle, the angles which are there, is going to be 30 and x, so it's going to be x plus 30. And the reason why we have square root 3 over 2 is because we know that if this is going to be the double angle of the compound angle of sine, then we have to change this one to be sine as well, so that you can write it in the form of sine that angle, including angle, is equals to sine to that other angle. That's the whole reason behind that. So this is going to be the general solution for D.